Number 3, the torque problem worksheet. So we have a rod 3 meters in length that's leaning at an angle of 25 degrees. So this theta right here, just put in what it is. That's 25 degrees. And you guys know from geometry that this up here is also 25 degrees, right? If you have two parallel lines and you cross them like that, you know, that angle and that angle are the same, right? So we got 25 degrees top and bottom. What else? So the length of this is 3 meters, like that. What else? We got a tension of 400 newtons. Now, as I walked around the room, I was looking at some of your work. Some of you did funny things with your tensions. Which way is the tension acting on this rod? What are they calling it? A rod or a pole? Rod. Which way is the tension acting on the rod? It's acting to the left. The rope is pulling to the left. It's keeping this rod from falling down, right? So the tension is straight towards the wall, right? Okay, so what I'm going to do is I'm going to get rid of this picture and I'm going to do a free body diagram for the rod. All right, so we'll go like this. Here's the rod, and then we're going to rotate this. All right, so free body diagram. The forces acting on the rod. We have tension. Tension, as I said, is pulling to the left. It keeps the rod from falling down. Where do we draw the weight of the rod itself? For a nice symmetrical object like this rod, where do you draw mg? Directly in the middle, because that's where the center of mass is. Oops. So we want this to go straight down. So mg for the rod goes straight down. And what else? Now look, where the rod touches the ground right here, there has to be a horizontal force this way. So what's that horizontal force doing? It's keeping the rod from slipping to the left. You know what I'm saying? Like if you put the rod like on a, you know, let's say that this surface right here were like frozen ice covered in melted butter. Is that rod going to stay like that, or is it going to go slip to the left? It would slip. So there has to be some force holding the rod to the right. And then there has to be some force holding the rod vertically. But I'm going to tell you what, these two forces are not going to matter, because what we're going to do is we're going to say that this point right here is the what? Axis. We're going to say that that's the axis. So why would those two forces not even matter? Because forces on the axis cause no torque. Should I review again why that's true? You guys know it? The torque equation, torque is equal to force times lever arm. What's the definition of lever arm? Nathan?
The perpendicular of the distance from the axis to the force.
It's the perpendicular distance from axis to force. It's the distance from axis to force. So what if the force is on the axis? What's the R going to be? 0. If your force is on the axis, the torque caused by that force is 0, because there's no lever arm, right? So these guys are not going to appear in our solution. Fx and Fy, they're just going to disappear, okay? Because they're on the axis and therefore causing no torque. Okay, so let's keep going. So let's do our distances now. So we have our axis specified. Now, the definition of lever arm, it's the perpendicular distance from axis to force. So let's figure out the lever arm for each of these guys. So look, what's going to be the lever arm for tension? Well, let's figure it out. So I'm going to extend the tension. I'm going to extend it. See, it just kind of goes like that. Okay. Can we draw a perpendicular distance up to that force? Yes. Yeah. So from the axis, here we go. this red line, notice that that red line, is it axis to force for tension? Yes. Is it perpendicular to the tension? Yes. This red line is our lever arm for the tension. So how do we get it? Well, the length of the whole rod is 3 meters. Okay, that's 3 meters. This angle up here is 25 degrees, and then so is this one down here. That's 25 degrees. So what's R going to be? Well, notice that we have a triangle here. See this triangle right here? So you're going to use trig. You use trig to find out what that R is, the perpendicular distance from axis to force. So let's look at sine of 25. Sine of 25. So what's opposite the 25? R. And then what's the hypotenuse?
3 meters.
The 3 meters. So we have R over 3 meters. So R is going to be sine 25 times 3 meters. So that comes out as 1.2679.
I rounded up to 1.3 meters.
Don't round. That's too. I'd go to the thousands place at least. You don't, because you'll get rounding error. I wouldn't round this, right? Don't round till the end. That's a good rule. Okay, so we got this R. This one is 1.2679 meters. That's the lever arm for tension. Okay, now what's the lever arm going to be for mg? For the weight of the rod itself. All right, so here's the axis. Axis is in the same spot. In fact, let me clean this up. I'm going to get rid of this fx. We don't even need that fx because it's on the axis. Get rid of that guy. Okay, so we go, boom. So from the axis, here's mg. From axis over to force. This is the R for mg. From the axis to the force, perpendicular. Bam! How do we get it? Well, 25 degrees. Now, what's the hypotenuse? So we got our triangle now is this triangle. Here's our triangle. What's going to be the hypotenuse of that triangle? 1.5. It's half of the 3, right? This hypotenuse is to there. The hypotenuse is 1.5 meter. So what are we using? Sine, cosine, or tangent? Cosine. So we go cosine 25 equals, wait, what are we doing? Adjacent, which is R. Adjacent over hypotenuse. So R will be cosine 25 times 1.5. So that one comes out as 1.3595. 1.3595 meters.
I rounded to 1.359.
Yeah, because actually I rounded that 5. That's fine. That's okay. You can go as long as you go to thousands place. It's good. All right, you guys with me? So now we got our lever arms. The rest of this is easy. So what we do, we sum the torques. Let's erase this. Okay, so now we're going to sum the torques. How many torques are acting on this rod?
There are
2.
2.
We got 1 torque, 2 torque, and then the axis is down there. Okay, mg. Is this force, is mg pulling on the rod in a clockwise fashion or counterclockwise?
Counterclockwise.
Clockwise.
What?
That's pulling clockwise. Look, it's pulling this way. The axis, you got to know where the axis is. The axis is over here. mg is pulling that way, which is clockwise.
Oh.
Okay? What is tension doing? Counterclockwise. Okay, so summing the torques, let's say that clockwise is plus, counterclockwise is minus. So we're going to go mg, that's the force, right? mg is the force. Then the lever arm is 1.3595 meters. Okay, then minus, for counterclockwise, minus tension, which we know. Actually, we know what tension is. They give it to us. What's tension? 400. So let's just put that in. 400. And then the lever arm for tension is 1.2679. meters, and then the torques cancel because it's not rotating. The torques will cancel. Okay, so now the only thing missing, hey, the guy who wrote this worksheet, or perhaps girl who wrote the worksheet, used 10 for gravity, okay? So plug in 10 for gravity, and then the only thing missing is m. So you solve this for m, and you get 37.3. Is that right? Yeah. You'll get 37.3 using 10 for gravity. That's the mass of the rod.